Okay, Assalamu alaikum students. Welcome to Transmission and Switching System course. So this is our week 3. So in week 3, we are going to study about basics of signaling and switching. So at first we will study about signaling. So what is signaling? So in any communication system, we need to initiate a call, maintain a call, and disconnect a call. So in telecommunication, the basic requirements are establishing a communication path, sustain and monitor the same during the period of communication, release the path at the end of communication. Say, for example, when we are calling someone, we need to establish the communication path. Then from the telephone operator, there should be some monitoring about the continuation of the the communication path and maintaining the quality of the communication pattern. Then when we finish our talking, there should be release. There should be release of the path at the end of the communication. So there should be some addition signaling activities. They are determine the facilities based on originator, receiver, and transmission medium. Like the present data session cannot happen at 14.4 kilobit per second since the link quality is not so good, and therefore the transmission rate is reduced to 9.6 kilobit per second. So this should be monitored. This should be monitored that what is the capacity of the transmission medium, or what is the quality of the transmission medium right now. So according to that quality, the bit rate should be updated. Now there should be supplementary functions to enhance the user experience, like caller ID, call waiting tone, etc. Now, signaling will carry additional signaling information like charging, routing, etc. Now, what is charging information? So, charging information is the data related to the cost or billing of a communication session. It includes details such as the duration of the call, the distance it covers, any additional services used during the call, and other factors that might affect the cost of the communication. This information is crucial for service providers to accurately bill customers for their usage. Okay. So this is actually the charging information. Now the routing information. So the routing information is the routing information determines the path that the data packets will take through the network to reach their destination. It includes details such as the source and destination addresses, intermediate nodes or network elements through which the data will pass, and any necessary routing decisions and or adjustments based on the network conditions. Routing information ensures that data packets are delivered efficiently and reliably across the network. Okay, so this is our routing information. You have to learn these definitions. So I have noted this in our slides. Now, we have to, in signaling, it needs to build error detection and correction based on payload to protect the data against noise in the channel. Okay, so if there is any, there can be different kinds of noise in the channel. So based on that, there should be different types of error detection and error correction methods. Now, what is payload? Payload is the main data. So while transmitting the data, the main data or the main information is known as payload. But with the main information, we need to add some additional information like error correcting information, like the destination address, source address. So without this additional parts, the main portion of the message is known as the payload. So I have given the definition of payload here as well. So this is essential data that the sender wants to transmit to the receiver. Okay. Now let's go to the next point. There are many kinds of signals which need to be transmitted between offices for an inter-office call, some of which include addressing. Now, in case of addressing, outpulsing of dialed digits, either pulses or tones called DTMF. Now, when we press some digits, or when we rotate the digits in our landline phone or in our mobile phone, so we are giving some address to the telephone office. So how that dialing is being processed? So there are two main methods of transmitting dialed digits. Okay, so I'm dialing some digits. So how this digit will be transmitted to the telephone office? There are two methods. One is pulse dialing. One is dual tone multi-frequency DTMF tones. So you have to learn these two definitions. So what is pulse dialing? Say, for example, this method involves sending electrical pulses over the telephone line to represent each digit. Say, for example, if I'm dialing 1, then it will generate 1 pulse. If I am dialing 2, it will generate 2 electric pulses. And if I'm dialing 3, it will generate 3 electrical pulses. So this is how the digits which I am dialing is being converted into pulses, and it is being transmitted to the telephone office. So each digit is encoded as a series of pulses. Pulse dialing is an older technology and is gradually being phased out in favor of tone dialing. Now, what is dual tone multi-frequency dialing? In this method, also known as tone dialing, involves generating pairs of specific audio frequencies to present each digit. So, for a representation of each digit, we are using a pair of audio frequencies. Okay, so a pair of audio frequencies, but their frequency will be different. When a button is pressed on a telephone keypad, it produces a unique combination of two frequencies that correspond to the pressed digit. So these tones are then transmitted over the telephone line to convey the dialed digits. Okay, so this is known as dual tone multi-frequency tones. So this additional addressing, information signals, supervision, this should be done by the telephone office as well. Okay. So in information signals, we will transmit dial tone, audible ring, busy back tone, recorder, etc. In supervision, there is off hook, on hook, and scissors. Scissors means the closure of line. Okay, the closure of line. Now, what is off hook? What is on hook? So, off hook means when a telephone handset or device is off hook, it means that the receiver has been lifted and the circuitry within the telephone is activated. Okay, so when I'm lifting up the telephone set, it is known as off hook. So this is the telecommunication language. So you have to remember all this. Now, what is on hook? Conversely, when a telephone handset or device is on hook, it means that the receiver is in its cradle or resetting position and the circuitry within the telephone is inactive. Just the opposite of off hook. Okay. Okay, we have discussed all this now. So in signaling, what are the points in signaling? So in signaling, we have to initiate a call, maintain a call, disconnect a call. There are transmission facilities, speed of present data session. There are supplementary functions, error detection and correction, pulse dialing and DTMF dialing, information signal, and supervision. Now about signaling. So just look at this example. So here, how a telephone call is set up, it has been illustrated in this figure. So there is one calling party. This one is the calling party. This is the exchange, PSTN, public switched telephone network, okay, the telephone office. The called party, the subscriber to whom I am calling, and the activity is listed here. So at first, the connection setup or organization. So this person is just pick up the phone. So when this person pick up the phone, there is one signal from this calling party to the exchange. So the activity is pick up phone, exchange senses off hook. Off hook means the headset is being lifted up. So exchange sends some off hook. Now the next step is the telephone network will allow this person to dial. So this person will listen the dial tone. Remember, when we lift up the headset and we hold it to our ear, we can hear the dial tone. Okay, we can hear some dial tone. So when we hear the dial tone, we just dial our number. So this person, in the third step, this person will dial the number. So it will dial the number either in pulse or in DTMF. So in fourth step, the network will collect the number. So the network selects the route to the subscriber, sets up the connection, called party ringing, calling party ring back. So the telephone network will set the connection and it will send some ringing tone to the called party. And at the same time, when you just imagine that you are dialing some number, and when ringing happen, you also hear some ringing tone in your phone as well, right? So so that calling party ring back. Okay, so that ring back means some ringing will be happening in your phone as well. That toot, 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 which means some ringing is happening at the subscriber or at the called party. Now, in the fifth step, information transfer, monitor and maintain. So, called party answers, exchange voice signals. So, a connection has been established and the exchange of voice signals is being done in this process. So, in the next step, connection release and bill. So, the two person hangs up. So there are the release of connection, and there are some call recording and billing information is being generated. So this is how a call is established from one point to another. Okay. So all this by all these 6 steps. Now the signaling methods. So there are two groups of signaling methods. One is user to network signaling. Another one is network to network signaling. Okay. So when a call is being connected or a call is being established, first the connection is set up from the user to the network. Then from that network to another network, the connection is being settled. So in this first point, this is between the end user and the PSTN. Example, dual tone, multi-frequency or ISDN. Now the second point, network to network signaling. This is the intercommunication between PSTN switches. The typical signaling activities will include on hook, off hook, digit dialing, digit collection, wake up the called party. So all this we have discussed in the previous slide. So skipping this. Now there are two groups of signaling we have discussed. So these are the signaling activities we have discussed. Now why signaling? Why we need switching? We have already discussed it. The n-square problem, we have already discussed that in point-to-point communication, we need a large number of links. So when the number of nodes increases, this type of network become impractical. Now, so this is how we need signaling or switching. So we have explained all this. So skipping this slide. Now, so if there are say for example there are the number of n, which means the number of nodes is 1000, then in that case we will need the number of links near to 5 lakhs. So in that case, the transmission tower, if that it is not practical, but just imagine that if the number of nodes are 1000, we needed 5 lakhs of cables, then the transmission tower will fall with time. So it is not a good practice. So it is not practical as well. Now, what is switching? Let us look at the very basic end-to-end telephony system. So this is one basic end-to-end telephony system. So this is one subscriber. This is the calling party. This is the local loop, and this is the central office. Central office means there is calling telephone, there is called telephone. The phone will be connected to switch. This is the switch or exchange or PSTNs. The exchange will have inbuilt intelligence to handle all activities of a telephone call. So note that it is a basic system we are talking about, and therefore many variants will not be discussed in this figure. It will have a telephone at the calling subscriber location and a telephone at the called subscriber location. The phone will be connected to switches or exchanges or public switched telephone network. The exchange will have inbuilt intelligence to handle all activities of a telephone. Inbuilt intelligence to handle all activities of a telephone call mentioned earlier on in the signaling slides. In a typical call between subscribers, there could be multiple exchanges and routes. So the explanation of the first figure, this is the first figure. This is the first figure. Then we will see the second figure, then the third figure. So in the first figure, the subscriber phones are connected to the PSTN invariably through copper wires. This segment is known as local loop. So this is known as local loop. So in the second figure, you can see that there is one subscriber. There is the switching. There is the switching office. So in switching office, two functions will be happening. One is control, one is networking. And this is how we will be connected to subscriber 2 by this switching office. So in the third figure, you can see that there are two number of switching offices, and in between we have trunks. So this one subscriber is in one part of the country, and this called party or the another subscriber is another part of the country. So this is one trunk call. This is known as trunk call. So we have to establish a line from this subscriber to the switching office of that city, then from the switching office of that city to the called parties cities will be connected. The switching offices will be connected. Then from this switching office, the called party will be connected. Now look at figure 2 and figure 3. So the PSTN also housing a switching office will have a control section to analyze what the subscriber wants and direct a network to do the appropriate switching. if subscriber 1 wants to talk to subscriber 2, the control network will park subscriber 1 in termination A and subscriber 2 in termination B, and they interconnect A and B for this particular call. So now there are two essential parts of the switching office. There are two essential parts. One is networking and one is controlling. Networking means when you are establishing some connection from subscriber 1 to subscriber 2, and controlling means when you are controlling the flow of data and the other processes. Say, for example, what should be the speed and about the billing information, the billing functions, it will be done by this controlling unit. So this is the basic switching used in telephony. So this is the switches. So say, for example, I have 5 users here and remaining 5. So total 10 users in this part and total 10 users in this part. So when my number 1 subscriber is being connected to number 8, it can be done by using this route. So we are using this 2 into 2 switch. So there are 10 users in this case, 10 users in this case. So in between, we have 2 switching offices. One is this and another one is this. So when this orange call is being established, this second switching office is free. So when the second call is being established, the second switching office will participate in that as it is free. Okay, so this is how the switching method is happening in the basic telephony system. Okay, now the different types of transmission. You all know about the simplex systems, semi-duplex systems, full duplex systems. Okay, so I will just touch all these points. I will not go in detail to this. So in simplex systems, there will be one way of communication. So this device will only transmit and this device will only receive. Okay, so at a time, only one device will able to, only this device is able to transmit. So unidirectional like broadcast or pagers like one-way traffic on the load. So this is the example of simplex system. Now in semi-duplex system, so in a semi-duplex system, either this user will transmit and this user will receive, or this user will transmit and this user will receive. Transmitting and receiving for a single user will not be available at the same point. Okay, so bidirectional, one direction at a time, like two-way traffic, but there is a narrow bridge in the path. So traffic can proceed at a time only in one direction. Okay, so one example has been given here. So in case of full duplex systems, this is one full duplex systems. So this device can transmit and receive at the same time as well, and this device can receive and transmit at the same time as well. So this is known as full duplex system. Now the asymmetric duplex system means both of the devices will transmit and receive at the same time. But when the uplink is in say for example, there is no parity in the communication pattern. Say for example, for data transmission with higher data rates in downlink. So the downlink is in providing higher data rate and the uplink is providing low data rate. So low data is being transmitted from this point to this point, but higher data is being transmitted from internet to the desktop. So the downlink is high speed here. So one side traffic has only one lane and the other side traffic has three lanes. So this is one practical example has been given here just for analogy. So this is the end for today's lecture.